Hello dear audience, thank you for being with me in another educational video of this popular programming language. In the previous video we talked about star expression in the continuous of the topic extracting elements from interval with arbitrary length. We want to mention another example that can be seen from this star expression discussion. For example, suppose you have a list of programmers working in an institution. For example, suppose that its name is, for example, PL stands for programmer list, for example. This is a tuple actually. This contains some data about every programmer in the institution. For example, their name, their age, for example. And the programming languages as they know actually. Suppose this tuple contains the programmer's name, her age, and the programming languages she is fluent in. Suppose we want to extract the list of programming languages for each programmer. Note that there are as many tuples as PL as there are programmers. Also, each programmer may be fluent in an unknown number of different programming languages, which is not necessarily the same for all programmers. In this case, it is better to act like this. For example, consider name, age, star, for example, programming languages is equal to such PL. Now if we run this cell, we will see what is the name, what is the age, and what is the programming languages. You can see that the last output is a list. This method has many uses. Note to a point that when you work with this method, the output is always a list. Another point to be considered is that if we now put this star expression for the first one, what will happen? For example, suppose that you are the owner of a business that you want to compare the average profit of the last 12 months with the profit of the current month. Consider a D-list for this purpose with these data in it. Okay, now if we define, for example, previous and now is equal to D, and then call. Now you can see that this is the last parameter of this list, and if we call the previous, you can see that the other ones are here in a list. We want the average, so let's apply the sum built-in function on this previous and divide it by into the len of the same list. Okay, and you can see the result here. Now you can compare the average profit of the last 12 months with the profit of the current month. Let's consider, for example, another variable named previous ones, for example, and just this one variable with the star expression is equal to d. You can see that this is an error, but if we act like this, consider other variables too, you can see that here there is no error, and we can also call the A, call the B, and these are two last parameters of the D list. Now this star syntax can be used in other places. For example, suppose you want to iterate over a sequence of tuples that have different lengths. For example, consider this R is equal to a tuple A 10, 40. Let's show them to you. Consider B as another tag here, 25, for example 63, and for example 71, and consider another tuple with tag C, and this time we want to have another string here. Okay. Pay attention to these tuples. These each have a tag and a different number of elements. And now suppose that we want to have a for loop that shows each of the tags of these tuples and elements together. First, we need to define the functions. For example, let's have a def PRA with the input argument of x and y. This is for printing tag A and x and y. Okay, let's define the other functions like this. PRB with the input arguments of x, y, and z. This is for printing this B tag and x and y and z together. And the last one, and def PRC with the input argument s, for example. This is for printing this C tag and the S string here. Let's say for the tag and the arguments inside R, if the tag is A, run PRA. If the tag is B, run PRB. Otherwise, run PRC. Let's have such a loop for tag, and we need to have such star expression here. I will explain it to you. In R, if tag is equal to A, PRA star arcs. Elif. This tag is equal to B, PRB star arcs, else PRC star arcs. Okay, you can see that the output is what we wanted. Actually, we need this star sign in these cases because the numbers of values as arcs are not equal together in every condition. So we need to use this star sign here. You saw that the task was done without error or with star expression, and so this is a wonderful possibility, and you can also combine this star expression with other possibilities and achieve more power. For example, in text processing when working with a split, for example, consider we have a line like this. For example, Ghazal, column 12.2, something like this. Again, column 84.9. Again, column 12, something like this. For example, A, B, C, D, @ HTB, again column, for example, something like this, again column, Python, again column, and 30. Okay. Let's act like this. We want these data and informations inside this string are not necessary. Actually, all of them are not necessary, and some of them actually are excuse me, are valueless. So we need to have the necessary one, the valuable ones, and throw away the others. So we can act like this. Data, for example, we can have programming language and age. Pay attention here. We want to apply the split function here, and we want to split this string where there is a column sign. Let's run this cell. Now let's call each variable. Name, Ghazal. Data, these are nonsense. Programming lang, this is Python. And age, this is 30. Okay. In this way, the whole string is separated from the place of the columns, and then it is used to extract the element. Since we have nothing to do with the data, we can use the throwaway parameter to be more efficient in terms of memory. It means that we can have the same expression here, but instead of this data we can use throwaway parameter, which is an underscore. You can see that this time these variables are working well, and we have what we wanted to have. Okay, consider another example. Consider we have a tuple. For example, there is a Python conference, and these are some information about that. And another tuple which is dedicated, which stands actually for the date of the conference. We can extract valuable variables from this name of the conference, throwaway variable, because we do not do anything with these two information, these two numbers actually. And then we want to have only the year of the conference, and the first two numbers inside the inner tuple is not necessary for us, so we can throw away them too. We can act like this, and this is the year actually. This is equal to R. Now let's call our precious valuable variables. Okay. So in this way you can throw away the unnecessary parts actually. Let's see another example. Consider a new list containing these numbers. For example, you can remove a head and a tail from it. Oh, okay, this is a fault here. Okay. For example, we can consider head and the others as a tail are equal to our list. So we can call them what is head and what is tail. Head is the first parameter and tail is the others. You can do a series of recursive algorithms in this way. For example, if you want the total members of a list, actually the sum of the total members of a list, you can act like this. For example, the sum input argument L, define a head and a tail as this L, and a return head plus applying the same sum on the tail. If tail is true and else, return the head itself. Now you may think that this is not necessary, but these are just for practice here. In some cases, in the complicated problems in industry, you need to do something like this, but a bit more complex. So I want to give you an insight about them here. I want to teach you the tips here. Okay, let's run it. As we said, zero value is false. So if the list is a single member, is a list containing actually just a single member, the sum will be equal to the value of the only member, and otherwise the members will be added together. Let's call it the sum with the same L as input argument, and you can see the sum of the members of this L list is returned to us. Okay, we finished this section. Here we will enter into the next discussion, that is keeping n last items. Let's have another topic here. Insert a square sign, a space, and we want to type keeping n last items. Okay, that means, for example, you have done a process on a text and you want to have a history of this process. For example, we want to find a phrase in a text and have the line containing it to better note the position of that phrase in the text. Actually, we want to add that phrase and the line containing it to the history every time this phrase is seen. In Python, this is done with the collections module. Maybe the question arises, why don't we use the list in such cases? The same can be done with lists, so why not use a list here? I will talk about this reason. First, let's work a little with this module. Of course, at first we need to import it. Okay. This module has a list-like structure called a DQ. Let's define D as an object of these collections, that DQ with an input argument of, for example, 2, 8, and 32. Okay, now let's see what the D is, and you can see this is the DQ of these parameters. We can do something with these DQs. For example, they support append 20. Okay, now let's see what is this DQ D, and you can see this is DQ of these arguments. The 20 is added from the right side of the DQ. And also there are another option to add parameter to the DQ from left, which is append left. And you can see if we apply it, this parameter is added from the left side. Actually, DQs supports pop. When you pop, the last parameter returns to you, and actually the last, the rightest parameter. Excuse me. We can do it from left to, and you can see that. Okay, this is missing, and you can see this left 20 is popped too. Now, why do we need to get acquainted with this module at all? Go to docs.python.org and search about collections. Let's go to docs. Search about collections and see its features. Now, why should you use these instead of the list? Pay attention to a point that adding and removing items in DQs is done with order of complexity 1. The same thing is done for lists with order of complexity n. Do you know what order of complexity is? Each algorithm is calculated with a complexity we do not want to explain in detail here. This concept is a very broad and significant topic in the design of algorithms, the explanation of which is beyond the scope of this training course. But in short, the smaller the complexity, the better, because that means the algorithm is done faster. This O1 means the running time of this code. It has nothing to do with the size of the DQ and the number of elements in it. But this is not the case with lists. ON means that the time spent to run the algorithm has a linear relationship with the size of your list. This means that DQs are obviously much more efficient in large data sets. The difference may not be significant in small sizes, but in larger sizes, the difference will be much more noticeable. So to some extent, now you understand why we are talking about DQs. Okay, now for more convenience, let's import this DQ itself and get release of using these collections in every lines of codes. Okay, let's have from collections import DQ. Okay. Let's have function here, search, input arguments, lines, pattern, hist, for example, here a default value 8. Let's define this PR lines as DQ of a DQ with a max length which is equal to this hist. Okay, now have a for loop for line in these lines. We need an if conditional 2 if pattern is available, is seen in the line, yield line, and these PR lines, which is a DQ, and then append these PR lines the same line. Okay, we are looking for a pattern which is actually either a word or a phrase. The maximum length of these DQs can be specified. This is a generator function. We will talk about these functions later, but just know that the characteristic of these is to have yield. The difference between yield and return is that the function does not stop after that. Let's give an example and implement. Before that, we add some cells. Like, let's have some cells here. Go on command mode, but select the 52 cell and press B sometimes in order to add some extra cells after the 52 cell. Okay, for example, consider A is equal to DQ with a max length of for example 5. Okay, now let's append the value, for example 10 to this A, and also show this A. You can see that this is our A with a single parameter A. Now let's append another parameter. You can see that there are two parameters inside our DQ. Now let's append another one. You can see that now there are 3 parameters inside our DQ. Let's append another parameter, and you can see that there are 4 parameters inside our DQ now. Let's append another one, which is 41, and you can see that now there are 5 parameters inside our DQ, which is the maximum length. Now if we append another parameter to this DQ, you can see that the append process is done, and the parameter is added to the right side of our DQ, but the first parameter which we appended to the DQ, which was number 10, was deleted from the DQ. If we add the 6th, the first will be removed. That is append continues, but the length is preserved. This is the same concept as keeping the last n items. So this function shows us the last 8. Inside the folder related to the chapter, we create a txt file called text1.txt. Let's go to the chapter here. Let's have a txt file and name it text1.txt. Okay. Now inside it, we want to find a text which is full of Python keyword. For example, we can benefit from the Wikipedia explanations about the Python programming language here. Okay, let's save it. In this file, for example, we want to bring such text that contains a lot of Python words. Then you can make this text a little more orderly. For example, its design philosophy emphasizes code readability, whole with the use of a significant indentation. For example, we do not need these words here, these numbers here. We can have a enter, have new line actually here, or a new line here. or another new line here. And we do not need these numbers for now. Okay, let's save it. Let's go back inside JupyterLab. We want to use this file. We want to consider lines as if and a pattern as Python. We consider this is equal to 8, for example. Does it 8 lines? 1, 2, 3, 4, 5, 6, 7, 8. Let's again have the Wikipedia site. Let's continue because we need more lines. Okay, something like this is okay. Say we just have more than 8 lines. I wanted to have more than 8 lines. Okay, so what we're going to do, we want to have a width open this text one.txt as if for line and PR lines in search with the input arguments f, Python, and 8 for p line in PR lines, print p line and with an space and print line and with such a space for the end of the line actually, and print for more separation, consider a dash and multiply it in 15. Let's run it. Text 1 is not defined. Okay, and this is a problem because this is not in the current working directory actually. We did not open this file. In the Okay, let's save it here. Let's download it, and let's open the file in the current working directory in the place of availability of our text1.txt. And now we want to okay, the problem is solved because we were not at the file which the text1.txt file was defined and created. So I used the addressing like this. You can see here, and the problem is solved. Okay, we used the last line to separate the lines. We don't get any result because we don't have Python with small p inside the text. But if we try with the bigger p, let's see the file. The Pythons are not written with small p, so let's change it and run again. You can see the result here. Okay, these are the lines containing a Python with big P. Okay, with large P. Okay. Let's now call the PR lines. You can see that this is a DQ like this, and let's apply the len function on it, and you can see that this is 8 because we defined that. We can run it with hist is equal to 2. For example, let's change this with 2, and you can see the output this time is like this. Now PR lines, you can see that this is very shorter, and len is 2. Okay, it shows 2 lines each time. Each time it adds a new line but deletes the existing first line from the beginning. Okay, this video ends here. Thank you for being with me in this video. I strongly suggest that you stay with us if you want to become an expert and exemplary programmer in the path of Python programming. Have a nice day.